Alright, so let's start with the Pva worksheet because I think this one was maybe the most difficult or challenging for you, and I want to be able to take some time and go over any of the questions you missed. So letter A was number 7. Letter B was 2. Letter C was 5. D was 9. E was 8. F was 6. G was 1. H is 3. I was 4. And J was 0. So again, take a minute, check those answers, and then if you're just looking at it and you're like, nope, I have absolutely no idea how you got that answer, I will gladly go over any of the questions you have. So we're good. We don't need to go over any of this. Oh, there we go. Okay, so C and F. So for letter C and letter F, we have the following. My camera's going to pop up for you in about a second here. There we go. So for letter C, it says the velocity of a particle for 0 to 9 is given in the graph above. At which of the following values is the particle speeding up? So in order to look at speeding up, we need two things to occur. To be speeding up, acceleration and velocity must both be positive or both be negative. So in order to be speeding up, acceleration and velocity have to both be positive or both be negative. And then in order to be slowing down, they have to be opposing signs. So if it's slowing down, then acceleration could be positive and velocity negative, or acceleration negative and velocity positive. I don't know why it won't fit. There we go. So in letter C, you were given the graph of velocity. So according to the graph of velocity, it had one point at which it crossed the x-axis, and that was at time t equals 4. So at 4, the velocity was 0. From 0 to 4, the velocity was positive. And from 4 to 9, the velocity was negative. Acceleration could be determined based on velocity. So if velocity is increasing, our acceleration is positive. And again, that's coming from that table I've created. So if acceleration is increasing, which is about 0 to 1.75, then acceleration is positive. If velocity is decreasing, acceleration is negative. So that was from about 1.75 to about 7. And then at the extrema on velocity, it begins to increase again. So that means acceleration is positive from 7 to 9. So what we need to look for is a comparison of the signs. So from 0 to 1.75, both acceleration and velocity are positive, therefore we're speeding up. From 1.75 to 4, velocity is positive, but acceleration is negative. Therefore, we're slowing down. From 4 to 7, both are negative. Therefore, we're speeding up again. And from 7 to 9, they're opposites, so it's slowing down. So then looking at the values they gave us, it said at which of the following values is the particle speeding up? It gave me the number 3. Well, 3 would be in this interval here, so not speeding up. 4 is at a changing point. So at 4, we aren't speeding up or slowing down. We're changing direction. So at t equals 4, it's changing direction. And I know that because the velocity is equal to 0. At 5, it's speeding up. And therefore, t equals 5 is my answer. So again, guys, as I'm going through these, if you have questions, you can unmute your mics. You can ask me things. Some of you are sending me chats. That's fine, too. So again, I am always looking for your input and feedback as we go through the lesson. The second one I got asked about was letter F. So it says a particle is moving along the x-axis. The position and velocity of the particle is recorded for various times. At what time is the particle moving towards the origin? So in order for the particle to be moving towards the origin, if our origin is sitting here, then the particle needed to be coming from the right and moving left, or it needed to be coming from the left and moving right. So what I would do is kind of plot out my velocity in my head and determine position. So position is given by x. Velocity is given by t, or v rather. So we know that when velocity changes signs, it changes direction. So velocity is positive, positive, and then negative. So that means from 2 to 4, we have a change in sign. So that means from somewhere in between 2 and 4, it changes direction. And somewhere in between 4 and 6, it changes direction. So my answers had to come from in between one of those two regions. And then we also know that the position is at 3. So on a number line, we know that at the beginning, it's at 3. So here's my beginning. From 0 to 3-ish, it's moving in the positive direction because velocity is positive. So if velocity is positive, it's moving to the right. However, at 2, my position is 0. So what that tells me is that somewhere from 1 to 2, it moved to the left. So it goes to 0, to -1, to -4, and then all the way back to 8. So it changes direction at between 2 and 4 and between 4 and 6. So the answer is going to be 6 because when the particle goes from -4 to 8, it had to move towards 0. Because the particle was moving to the left, then to the right, and passes the origin. Okay. So what I want to do is see what you got for clue. So at this time, each of you in the chat, and it will only go to me because of the way I have the chat set up, I want you to tell me what answer you got for the clue game. So who was the murderer? Where did the murder occur? What was the weapon? And what was the motive? So go ahead, take a minute, and in the chat on Zoom, type me out your answer. Alright guys, it looks like everybody was able to catch who the killer was. So we know that Black Widow took out Spider-Man. Everybody was confident in that. Where we kind of started to have disagreements is in question 2, which is where did the murder take place? So the murder took place in the library. So let's talk about why or how it took place in the library. Okay, so it took place in the library because it says the position of the vehicle is moving along that line. At what time is the particle moving toward the origin? So again, we are looking at velocity. So we need v of t. So the velocity in this case is 3t squared minus 6t. Factoring out a 3t, we get t minus 2. So what that means is the velocity changes direction at 0 and 2. And that means we need to look at s of 0. So Black Widow's position at 0 was -6. Black Widow's position at 2, when velocity or Black Widow changed direction, the particle, was at -10. And then the position after, so let's look at s of 3, was -6. And you could look at the position of the function before, so maybe at like 1, which is 1 minus 9, or -8. So what we can see is the particle is getting more and more away from the origin, and then it's starting to come back from the origin. And if you compared the velocity, what we know is the velocity at 0 is 0. The velocity at 2 is at 0. Velocity at 1, well, 1 minus 2 is negative, positive, it would be negative, so that tells me it's going left. Velocity at 3 would be positive, so that tells me it's moving to the right. So the velocity or the particle changes direction at 2 seconds, and it goes from moving to the left to the right. So when it goes and changes directions from left to right, it would start to be approaching the origin after that change in direction. So that tells me at 3, it's moving towards the origin because it's going negative, 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 more positive, going to the right. 3. And in letter or number 3, you should have gotten 100 kittens. So I think we all got the 100 kittens. That's simply finding average velocity. So I talked to a bunch of you yesterday on the Zoom, and average velocity, if you did not recall, is change in position over change in time. So in this case, the first time or first position was pi halves. The second one was 0. So it'd be pi halves minus 0. And then in order to get that, you would just plug into the position function, which was given to you in the problem. And then number 4, what was the motive of the murder? Well, they think that spiders are creepy. And again, that's coming from the speeding up and slowing down. So in order to get that problem, you would need to find your acceleration, and you need to compare velocity and acceleration. So we were given velocity. We would need to find acceleration. You would need to find the speed, or basically the velocity and acceleration at 3. So V of 3 would be 9 minus 33 plus 2, which is negative 22. A of 3 would be 2 times 3 minus 6, so negative 5. So if velocity is negative and acceleration is negative, then the particle is speeding up because they are both negative. Okay. And then the last part that you had to do for today was looking at the particle motion and looking at example number 2 from that handout. So, here we go. The velocity at that point is equal to 1 minus 9 over the quantity t plus 1 squared. We needed to find when velocity is 0. So 1 would never equal 0. Negative 9 will never equal 0. T plus 1 squared will equal 0. So basically what I like to do when I get these problems is get a common denominator, because then I don't have to worry about looking at this to try to find the zeros or the roots. I can, because if I were going to do this problem, I would have to set this equal to 0, move that over, cross multiply, etc. I like to just get a common denominator and see what gets moved up to my numerator, giving you time t equals 2. And we're going to be doing a lot of that in lesson, I think it's 4.4, optimization, so chapter 4, lesson 4, where we focus a lot on minimizing and maximizing functions. And then what I do is, once I have this velocity, I use that when I find the derivative for acceleration. So here's my acceleration. So again, when we're talking about these types of functions, we need to find position, velocity, acceleration, find the zeros of velocity and acceleration, and then compare the signs at those points around them. Okay. And again, you can see down on position, I like to show exactly what's happening. So all of the dots represent the function value at those points. So initially the position is at 10. At time 1, the position is at at 6.5. Sorry, not negative. But then we know that at 2 seconds, it starts to move to the right. So it's going to change direction. So at 2 seconds, it's at 6. So it starts at 10, goes to 6, moving left. At 2 seconds, it changes direction. So now it's moving to the right. And you can find 3, 4, or 5 seconds to see how quickly it's moving to the right. We know that it's speeding up as it continues to the right. So you can see that it's going quicker and quicker. The distance from 3 to 4 is greater than the distance from 4 to 5. And if you continue to compare them, the distance would get smaller and smaller and smaller because it's speeding up. Okay. So what I want to do for the remainder of class today is really work on reviewing for our Chapter 3 test, but reviewing all sorts of material. Hopefully you were able to do that through the Delta Math yesterday. I know the problems were varying in difficulty. If there's a problem you had and you're like, I still have no idea how to do it, even after all of the answers popped up, just let me know and I will gladly work through any of those problems with you. So what I want you to do now is go ahead and take out the stations if you have those printed. If not, you can have them open up on your screen. I will say though that there's quite a bit that goes with them. So we are looking at the stations. I don't know if I still have mine in my download folder. No, I just have the Big 10. So we are looking at the stations review. Which is derivatives through implicit. Oh, I went on my OneDrive. I don't want to do that. It should look like. So basically what they're going to be is some of them are multiple choice, some of them are not multiple choice and you have to work through them. So it'll be questions like this that are multiple choice or free response. They are written in AP style. So it says the function g of x equals is not continuous at x equals 2 because, and then you're supposed to pick the reasoning why. So, g of 2 does not exist. If I look at the domain of this, x is greater than 2, x is less than 2, neither of these have an equal to 2, therefore g of 2 does not exist. So statement A is true. The limit as x approaches 2 does not exist. So I would compare the left-hand limit to the right-hand limit. So the left-hand limit would be the x values less than 2. So that is 4 minus 4, which is 0. So the left-hand limit is 0. The right-hand limit would be x values greater than 2, which is 2 squared, or 4. So the left-hand limit is 0. The right-hand limit is 4. Since 0 does not equal 4, the limit does not exist. And then it says the limit as x approaches 2 of g of x equals g of 2. Well, if the limit does not exist, it can't equal the function value. So A, B, and C represent the three parts to the continuity definition. and g of x fails all three parts of the continuity definition. Therefore, answer D is correct, that all three statements are true for A, B, and C, and g of x fails the definition of continuity. So those are the types of questions we're going to be reviewing. Those are the types of questions that, I'm going to be asking of you next week when we take the multiple choice part of our exam, because it tests both your ability to recall the definition and your ability to understand continuity beyond memorizing the definition. So what I want to do is, there are 5 of you. My goal was to put you into breakout groups. So I'll put you into rooms of 3 and 2. And I'll give you guys some time to work on those stations in those groups. I was kind of hoping more kiddos got on today, but they did not. And we will meet back up tomorrow to go over them, but I'll stay on the Zoom call with you to answer any questions you have on the stations within your groups as you're working.